Welcome. This is for CIE AS level 9709 practice paper 4. So we shall try to solve these questions from the practice paper 4 till now. We have done practice paper 1, 2, 3. Now this is going to be the fourth practice paper. So coming to the first question. First question, a fair spinner with 5 sides numbered 1, 2, 3. A fair spinner is there with how many sides it is there? 1, 2, 3, 4, 5 with 5 sides, and the numbers are nothing but what? 1, 2, 3, 4 are being written there. Now, what is being told? It is being told that, let's start this. The score on each of the spinner of the number of the sides on which the spinner lands. Then, find the probability that the score 3 is obtained for the first time in the, what is this, fifth spin. In the eighth spin, it is obtained in the eighth spin. So which score is that? So for these kind of questions, so first of all we should be knowing it out that it is happening in the eighth spin. So it's happening in eighth spin. So let's do it out. What happened to the remaining 7 spins? First spin did not get, second spin did not get, third spin did not get, fourth spin did not get, fifth spin did not get, sixth spin did not get, seventh spin did not get, and eighth spin was a success. Probability of a success is going to be 1 upon 5, and probability of failure is going to be nothing but how much? 4 upon 5. So 1 upon 5 is 4 upon 5, you can see it out. It is 7 times. 4 upon 5 whole to the power of 7 and 1 upon 5 whole to the power of 1. Simplify that, 0.0419 is going to be the answer. Find the probability that fewer than 6 spins are required to score 3 for the first time. Fewer than 6 spins means it can be either be one spin, it can be either be a one spin or two spins, or it can be three spins, or it can be four spins, or it can be five spins. Fewer than 6 spins. So probability of success is nothing but what? 1 upon 5. Probability of failure is nothing but what? 4 upon 5. Now one spin. Success is nothing but is required it out only in one spin. So what am I going to do? So it's going to be 5C1. So 5C1. So one spin, and I will be getting it out whole to the power of 1. So first spin I got it out, and remaining spins I did not get it out. Then 5C2. 2 spins and 4 upon 5 to the power of 3. Then it's going to be 5C3. 1 upon 5 whole to the power of 3. 4 upon 5 whole to the power of 2. Then it is 5C4. 1 upon 5 whole to the power of 4. 4 upon 5 whole to the power of 1. And 5C5. 1 upon 5 whole to the power of 5. 4 upon 5 whole to the power of 0. Simplify all this, 2101 by 3125, which is going to be 0.672. Now coming to question number 2. This is from a probability, and this is what? A tree diagram. We can do with tree diagram or without tree diagram also. We can do that. Question number 2. So what does it says? Georgia has a red scarf, blue scarf, and a yellow scarf. Red, blue, and an yellow. It's going to be red, blue, and yellow. Let me choose yellow color and yellow. Now probability of your blue scarf, yellow scarf, blue scarf is what? 0.2, 0.45, and 0.35. When she wears a red scarf, she wears a hat. So compulsorily she will be wearing a hat. So 1. Not wearing a hat will be 0. When she wears a blue scarf, she wears a hat for a probability of 0.4. So probability is 0.4. Not a hat is going to be nothing but what? 0.6. Then yellow hat or yellow scarf, she wears a hat is 0.3. Not a hat will be 0.7. Next, what is he asking? Find the probability that on a randomly chosen day, Georgie wears a hat. Wears a hat means red and a hat, blue and a hat, yellow and a hat. So what is it going to be? 0.2 times 1 plus 0.45 times 0.4 plus 0.35 times 0.3, which is going to be 0.485. Next, find the probability that on a randomly chosen day, Georgie wears a yellow scarf given that she does not wear a hat. So probability of yellow given that does not wear a hat. So probability of not wearing a hat is coming to the denominator, and numerator is yellow intersection not wearing a hat. So not wearing a hat will be, so red and not wearing a hat, which is 0.2 times 0, plus blue and not wearing a hat, 0.45 times 0.6, and yellow and not wearing a hat. Yellow and not wearing a hat will be 0.35 times 0.7. 0.35 times 0.7. So that's going to be the answer. So for the denominator. Now we know that this is for red, this is for blue, and this is for yellow. Yellow goes to the numerator, so which is 0.35 times 0.7. Simplify that, 0.245 divided by 0.515, which is going to be 0.476. That is the answer. Now coming to question number 3. Question number 3 is a graph related question, and that too a histogram. So remember, for a histogram we need to draw it out. What are we going to draw? The frequency density. Remember, it should be drawn with a frequency density. At a summer camp, an arithmetic test is taken by 250 children. Then the times taken by the nearest minute is given over here. Then find the histogram. So first of all, what am I supposed to do it out is, so what is this? Make it out continuous. So subtract, this is 0.5, this becomes 30.5, and this becomes 30.5 and 45.5. Subtract 0.5 from the left side, add 0.5 to the right side. 65.5, 75.5, then again 75.5 and 100.5. Now I need to calculate the frequency density. So the class widths over here is 30, over here the 15, over here it is 20, 10 and 25. The class widths means highest minus least. Subtract these two, you should be getting the class widths. Then it is 21 divided by 30, which is 0.7. Then it is 30 divided by 15, which is 2. 68 divided by 20, which is 3.4. Then 86 divided by 10, which is 8.6. 45 divided by 25, which is 1.8. Now I am going to draw the x-axis and y-axis. We are in question number 3, and in another few minutes we'll complete question number 7. Okay, so I am going to draw this histogram, and it is 0.5 to 100.5. So I may start with 0.5, 10.5, 20.5, 30.5, 40.5, 50.5, 60.5. I can see that it is not been completed. So what can I do? I can make it as 0, 20, 40, 60, 80, 100. This way it can complete, and maximum is nothing but 8.6. So 2, 4, 6, 8, 10. This is frequency density. This is frequency density, and this is going to be what is that? Time taken in minutes. Time in minutes. From 0.5 to 30.5, it is 0.7. 0.5 to 30.5. So 0.5 is somewhere over here middle. 0.7 So there are 10 lines and each line 2 means 0.2, 0.2, 0.4, 0.6, 0.8, 0.7 is over here till 30.5. This is 20, 22, 24, 26, 28, 30, 30.5. Next, between 30.5 to 45.5 it is 2. 30.5 to 40.5. So this is still 40. 40.5 means somewhere over here. Then it is 45.5, not 40.5, 45.5. So this is 42, 44, 45.5, somewhere over here. Then 45.5 to 65.5 is 3.4. 45, 3.4. This is 2.2, 2.4, 2.6, 2.8, 3, 3.2, 3.4 till 60.5. Till where it is 65.5. 65.5. This is 60, 62, 64, 65.5. Then from 65.5 to 75.5, it is 8.6. 65.5, 8.6. This is 8, 8.2, 8.4, 8.6. 75.5. This is 66, 68, 70, 72, 74, 75.5. And finally 75.5 to 100.5, it is 1.8. 1.8 up to 105.5, 100.5. 100.5, yes, that's the answer. State the interval in which the median is there. Median means nothing but what? The middle number. So 150 divided by 2, 75th observation. Where is the 75th observation? So we will be writing the cumulative frequency 21, 51, 51 plus 68 is nothing but what? 119. 119 plus, but this is 250, not 150. So I take it is 250. So I make a correction over there. 250 divided by 2, which is 112.5. 112.5 means 113th observation. Where is the 113th observation? So obviously it will be coming in median. 21 plus 30 is 51. 51 plus 60 is 119. 119 plus 86 is nothing but what? 205. 205 plus 45 is 250. Now I want the median. Median means the middle number, 113th person. Where does the 113th person comes? Between 46 and 65. Between 46 and 65. Given estimate of the mean is 61.05. State which feature of the distribution accounts for the median and the mean is different. Because distribution is not symmetrical. Distribution is not symmetrical. Means we can see that suddenly it rises up over here, then it is less over here, again it is high over here. This is maximum, this is high, and this is less. So if at all it would have been uniform, then it would have been mean and median would have been the same, but it is not the same. So therefore what it says, they will be totally different. Now coming to the next question, question number 4. Question number 4. The weights of a leopard in a particular region are normally distributed with a mean 55 grams, 55 kgs, and standard deviation 6 kgs. The mean is 55 kgs and the standard deviation is mean equals to 55 kg. Standard deviation is 6 kg. Find the probability that the randomly chosen male leopard lies between 46 kgs and 62 kg. So probability of second one minus less first one, 62 minus probability of x less than 46. So probability of z less than 62 minus 55 divided by 6 minus probability of z less than 46 minus 62 divided by 6. 46 minus 55 divided by 6. So probability of z less than 7 upon 6 minus probability of z less than negative 1.5. So this will become probability of z less than 7 upon 6 minus 1 minus probability of z less than 1.5. So this will become 0.8784 minus 1 plus 0.9332. Simplify that, 0.812. The weights of a female leopards in this region are normally distributed with mean and standard deviation. It is known that 25% of the female leopards are less than 36 kgs. Less than 36 is 25%. So probability of z less than 36 minus mu by sigma equals to 0.25. But mu is nothing but how much he gave? 42. So probability of z less than minus 6 by sigma equals to 0.25. But what I can do? 1 minus probability of z less than 6 by sigma equals to 0.25. So probability of z less than 6 by sigma equals to 0.75. So 6 by sigma equals to 0.75 is 0.674. So sigma equals to 8.90. The distribution of the weights of the male and female are independent to each other. A male and a female leopard are chosen at random. Find the probability that both the weights are less than 46 grams or kgs. So for male, I'm going to find it out less than. So less than 46. What is less than 46? We have found it out over here. Less than 46 is 1 minus 0.9332. We have already found it out over there. Less than 46 is 1 minus 0.9332, which is nothing but 0.0668. Now, this is for male. Now I need to find for female also. Probability of x less than 46. So which is probability of z less than 46 minus 42 divided by 8.90, which is probability of z less than 0.449. See from the table, 0.6732. Now both should be less than 46. So male is less than 46, which is 0.0668, times female is also less than 46, 0.6732, 0.0450. Marco has 4 boxes labeled K, L, M, and N. He places them in a straight line in the order of K, L, M, and N, with K on the left side. K, L, M, and N. Marco has 4 colored marbles: red, green, white, yellow. He places a single marble in each box at random. Events A and B are defined as white marble either can go to L or M. So what will be the probability of A? Probability of A is going to be 1 upon 2. Now I have to find it out. Probability of B. What is probability of B? A red marble is to the left of both green and yellow marble. So left marble should be on the left. So red is on left of both yellow and green, or green and yellow. So first of all, what am I going to do? That is, we have the positions 1, 2, 3, 4 positions we have. So what I can do, I can fix red over here, or red at the second, or red at the third position. So I can fix red marble either at the position number 1, position number 2, or position number 3. If I'm, what is it? If I have position number 1 and position number 2. So if it is at position number 1, if the red marble is at position number 1, what will happen to the we have to do? So we have to choose 2 out of the remaining 3 positions, because we have to choose green and yellow over here. Green and yellow over here. So we have to choose 3 places are left over. 3 places, and we have to choose either yellow and green. So this can be done in how many ways? 3C2 ways. 3C2 ways. Then once I done it out in 3C2 ways, those 2 things again can be arranged among themselves in nothing but what? 2 factorial ways. So which is going to be nothing but how much? 6. So it's going to be 6 ways. If at all red is at the first position. Now if at all red is at the second position, red is at the second position, then in that case, what should I be doing it out again? Green and yellow should be over here itself only. Green and yellow should be over here itself, which is just only one way. Then again, it can be yellow and green also. This is another one way. So therefore, totally how many ways are there? Only two valid arrangements are there. So now if red is at the third position, if red is at the third position, we cannot fix green and yellow over here. Green and yellow cannot be fixed over here. So for this one, what is going to be there? 0 is going to be the answer. So totally how many positions I have it out? 6 plus 2, 8 ways are there. 6 plus 2 totally is going to be 8. Now the probability of B will be nothing but what? 8 divided by 4 can be arranged in 4 factorial. So 8 upon 24, which is 1 upon 3. That is probability of B. Now I have to find it out probability of A intersection B. So what is that A intersection B? W is in L or M and R is left of green and yellow. So W is in, so what is the arrangement? We have the arrangement K, L, M, N. Now if W is already, white is already in L. Now what is the thing is R compulsorily should be there in, R should be compulsorily there in K. Then only we can get it out green and yellow over here. So it's going to be that one way. So green and yellow or yellow and green. So how many ways it is that? Two ways is that. Now again K, L, M, N. Now if R is in the first position, if R can be in the first position and W is over here, green and yellow can be over here. Green and yellow can be over here. W is fixed at 3 and then in that case again, see carefully, I am fixing so if it is at 3, green and yellow, what is this? R can be at position 1, green and is at second position and under L and the yellow is in the fourth position. So this is a valid position. Now G and Y should be at second and fourth. G and Y at positions 2 and 4. G at 2, what it says is invalid because it is not right to that of the R. So this is only one position over there because he is saying that in this B, red marble is left to both green marble and yellow marble. This is one of the way. And is there any another way? Then again I can write Y and G with R over here, W over here. So this is two ways. Then is there any another way if at all I can do that? So that's all. These are the only two ways. Because what it says, if I shift R over here and W over here, it has to be G and Y, which is not possible. So therefore, totally how many ways I have? I have only 4 ways I have. 4 out of total how many ways again? 24, which is 1 upon 6. So probability of A intersection B should be equals to probability of A times probability of B. So probability of A intersection B should be equals to probability of A times probability of B. So this is 1 upon 6. This is probability of A was 1 upon 2 and B was 1 upon 3. 1 upon 2 times 1 upon 3. Are they equal? Yes, they are equal. So it is independent. Now coming to question number 6. A new village social club has 10 members, of whom 6 are men and 4 are women. The club committee has to be formed. A club committee has to be formed. 4 men. What is that? Men are 6 and women are 4. How many members have to form it out? 5 members. What is the condition? In how many members it can be chosen? If at least 2 men and 1 woman. 1 woman, at least 1 woman, so 4. So 2 women, 3. 3 women, 2 men. That's all. So it's going to be 6C4 times 4C1 plus 6C3 times 4C2 plus 6C2 times 4C3, which is going to be 60 plus 120 plus 60, which is 240. The 10 members of the club stand in a line for a photograph. How many different arrangements of 10 members? If all men stand together, 6 factorial. All women stand together, 4 factorial. They again can themselves start them among themselves in 2 factorial ways, which is 34,460. 34,560. For a second photograph, the number of the members stand in 2 rows with 6 in the back row, 4 in the front row. Ollie and his sister Petra are the 2 other members of the club. How many different arrangements are there for the 10 members in which Ollie and Petra stand next to each other in the front row? So, for the second member graph, the members stand in 2 rows. They are standing in 2 rows. 6 in the back row and 4 in the front row. 6 over here and 4 in the front row. Ollie and her sister Petra are the 2 members of the club. Ollie and Petra. How many different arrangements are there for the 10 members in which Ollie and Petra stand to next to each other in the front row? So they are standing next to each other in the front row. So already Ollie and Petra are already there. So how many are left over? 2 more are left over. So out of 10, minus Ollie minus Petra. Minus Ollie minus Petra equals to nothing but what? 8 people. 8 people have to be selected for 2 places and arranged. So it's going to be 8p2. 8p2. So remaining 6. 6 people can go over here in how many ways? 6 factorial ways. 6 people in 6 factorial ways. Then times, now this Ollie is 1 unit. This is second unit and third unit. These people can be done in how many ways? 3 factorial ways. So this is going to be the answer, which is 241,920. Because Ollie and those 2 people can be arranged. This is Ollie and Petra, and another 2 people can be done in 3 factorial ways. Question number 7. So coming to question number 7, what is that? Find the number of ways in which the word, 9 letters of the word delivery. 9 letters of the word delivery are being arranged in which all 3's are together and 2 D's are not next to each other. So arrangement are all 3 E's together minus 3 E's together and 2 D's together. If I subtract it out, then I will be getting it out in this way. So delivered, 3 E's are together. E, E and E. So what am I left over with? D, L, I, V, R, D. 1, 2, 3, 4, 5, 6, 7. 7 factorial divided by 2 factorial. Why this is 2 factorial? For D's. Then minus 3 E's are together. E and E. 2 D's are together. D and D. So LIVR. So this is nothing but what? 6 factorial. So 7 factorial minus divided by 2 factorial minus 6 factorial, which is 1800 ways. Part B, find the probability that a randomly chosen arrangement of 9 letters 1, 2, 3, 4, 5, 6, 7, 8, 9. So what am I doing? I am arranging all these 9. 7, 8, 9 and 1, 2, 3, 4, 5, 6, 7, 8, 9. There should be 4 letters between D and D. So D and D, D and D, and a D and a D. So there are only 4 ways. 4 ways. Then 4 choose one, or 4 out of these 4 ways I choose one. Remaining now delivered, 2 D's are left over, 7 are left over now. 7 places can be placed in 7 factorial divided by 3 factorial. That's all. 7 factorial divided by 3 factorial because of E. So this is going to be 3360. But what is he asking? Probability. So probability will be equals to 3360 divided by total number of ways. What is the total number of ways? Total number of ways we have to calculate, which is going to be 9 factorial. 9 factorial divided by, in that delivered, 9 factorial divided by 3 factorial, 2 factorial. So which is 3360 divided by 30,240, which is going to be 1 upon 9. 5 letters are selected. Now what is that? 5 letters are selected. Find the number of different selections in 5 letters, include at least one D and one E. So it is D, E and 3 blanks, D, double E and 2 blanks, D and triple E, then D and D and E, then DD, EE, and finally DD and triple E. So over here remaining will be 4, 4C3, 4C2, 4C1, then 4C2, 4C1, 4C0. So this is going to be 4, 6, 4, 6, 4, 1. Add them all, 25. That's going to be the answer. So that completes this paper. See you in the next paper. Bye.